4 point charges, each of plus q, are rigidly placed at the four corners of a square planar soap film of side A. The surface tension of the soap film is gamma. The system of charges and the planar film are in equilibrium, and A is given by, that is the side of the square is given by this expression. Now, in this expression, we have this value n. We have to determine the value of n, and we are given that alpha is a constant. Now, this question is being taken by us from IIT JEE 2011 paper. Now, first of all, my suggestion to you is that pause the video and try this question by your own and then proceed to see the solution. Now we will solve this problem. For every question in physics, I suggest you to try to analyze the situation by drawing diagrams. So let's draw the diagram. We have four charges which are placed at four corners of a square. The side of a square is given as A. That is, this side is A. Now, these charges are plus Q, plus Q, plus Q and plus Q. We are also given that this is a soap film of surface tension gamma. The system of charges and the planar film are in equilibrium. Now, we have to analyze the situation. So, this is our diagram. We can see if we take any particular charge, let's suppose we take up this charge. So, this charge will experience electrostatic force of repulsion due to this charge and this charge. Now, due to this charge, the force of repulsion will be along this direction. Due to this charge, the force of repulsion will be towards this side, and due to this charge, the force of repulsion will be along this direction. Now we have to add these forces to get the net force. Now it is obvious that due to this charge and this charge, the force will be equal, and hence, and also they are inclined at 90 degree. So the net force will be along this direction only. But let's first see what is the value of F. Since this side is A and also this side is also A, the value of F will be K Q upon A square, that is KQ square upon A square, where K is 1 upon 4 pi epsilon naught. Also, due to this charge, the force will be F dash, and F dash will be K Q upon, what is this distance? That is the diagonal of square. If this side is A, this side is also A, so the diagonal becomes root 2A by Pythagoras theorem. Hence, this force becomes KQ square upon 2A square. Now, what is this value? This is F only. So, F dash can be written as F upon 2. Now, from the diagram, we can write this as F upon 2. Now, if we take up this charge and draw the free body diagram of this charge, we will have one force here, and one force here. This force is F, this is F upon 2 and this is F. Now see that if we resolve these two forces, one along this direction and other along these directions. So we can see, since these forces are equal and inclined at 90 degree, these component of the forces will cancel out each other and hence the net force will be along this direction only. So we can resolve and write up this diagram as this force along will be F upon 2 plus, since these forces are equal and inclined at net 90 degree, the net force will be root of F square plus F square, which is root 2F. So this becomes F by 2 plus root 2F. Now seeing the original diagram, this is the net force on this charge due to all the charges. Now since the charges are in equilibrium, there has to be some force along this direction. Let's see what is the value of that force. Now since this is a soap film, due to surface tension, due to the stretch of the soap film, there will be a force which will be, or which will try to shrink this square. Now to see the direction of this force, we can see that if we have a frame like this and there is some movable rod and we dip this frame in a soap solution, so that this becomes a soap film. Now experimentally, or we can say that this movable wire will tend to move in this direction. Hence we can say that this wire, that is this side, will try to move along this side and hence the net force on this frame will be along this direction. Similarly, the net force on this side will be along this direction. So we can write the net force in this direction will be, suppose if this force was F and this force was also F, so this becomes root 2F. Now we have to, let's say this is F naught, because this is also F, so let's not confuse. Now we have to see the value of F naught. Since surface tension gamma is force per unit length, so here the length of the wire is A. So F naught becomes gamma times A. But we have to be very careful that this is a soap film, and if we see from this side, that is above the table, we will find one free surface, and also if we see from below the table, we will also find a free surface. So in other words, we can say the soap film is in contact with air with two faces. So the net force on the wire will be due to the two faces. So the F naught force will be 2 times of this value. Although this is not very important in this problem, but still we have to understand each and every part of the problem. Now, this force that is acting on this charge due to surface tension is root 2 F naught. That is root 2 F naught. The value of F naught is 2 gamma A. Now, this force will balance by the force of electrostatics, that is F upon 2 plus root 2F. Now this is our equation of equilibrium. Solving this, we can write 2 root 2 gamma A is equal to F common 1 upon 2 plus root 2. Now the value of F was k q square upon a square 1 upon 2 plus root 2, and this becomes 2 root 2 gamma A. Finally, we can write a cube is equal to kq square upon 2 root 2 gamma into 1 upon 2 plus root 2. Note that k here is 1 upon 4 pi epsilon naught, which is a constant. Now, let us say that this whole term is a constant. Let us suppose this is some constant beta. Now, note that this doesn't include this gamma. So, this is beta. So, the rest of term is beta q square upon gamma is a cube. And hence, a is equal to beta a square upon gamma 1 upon 3. Now, if we take beta out of this cube root, this becomes beta 1 by 3 a square by gamma. Sorry, this is not a square, this is q square. And this is a cube. This becomes cube root. So, this becomes q square to the power 1 upon 3. And according to the question, this is given as alpha. So, we have written a in the form of alpha times q square upon gamma to the power 1 upon 3. So, according to the question, the expression was alpha q square by gamma to the power 1 upon n. Comparing, during the question, it's given as q square by gamma 1 upon n, which means the value of n is 3. So, this is our answer. Now, note that as we have discussed that this force is twice due to the two free surface or the two contact surfaces, but this all is constant. So, this doesn't matter in this type of problem. But we still have to focus on every part of the problem so that we are building concepts here. Now, I hope you got this problem. Let's move to our next problem.